Okay, let's continue talking about portfolio theory. Let's look at a two-space, again, that has mean historical returns on the vertical axis and standard deviation of returns on the horizontal axis. And we'll look at the two stocks, X and Y. Now, I mentioned earlier that if the correlation coefficient between the returns of X and Y is less than the ratio of standard deviation of X to standard deviation of Y, that the curve would bend back like that. That curve is the feasible set. And this is the two stock case again. Okay, but an important question is, what is the possible behavior of that line? For example, even if this were not to be true. And even if this is true, is this exactly what the line always looks like? And so now I'll show you in red a triangular region in which that feasible set in the two stock case must lie. And it looks like that red triangle. It has to be somewhere in there, okay? And if the feasible set is bending backwards, then we know this is true. If it's not bending backwards, then, for example, that would look something like this. Let me show you. It was something like this is when that doesn't bend backwards. Or the straight red line that we see right there, okay? And those are possibilities. Everything else bends backward. This is the most extreme case where you have, I'll chart it in the green, you have this. Two straight line segments that actually hit the vertical axis. That's a certain circumstance that we'll talk about here in a bit. But this red triangle is the triangular area in which the feasible set must lie. Okay, so what makes it lie elsewhere? But before we can look at that, let me just remind you of something from basic statistics. Definition of the correlation coefficient between X and Y. This is also known as rho X comma Y. Okay, is equal to the covariance between X and Y divided by the product of the standard deviation of X times the standard deviation of Y. In different notation, this would look like this. Rho X comma Y equals covar XY divided by sigma X times sigma Y. That's the same formula, just different notation. Okay. All right, now this implies the following. I can multiply both sides by sigma X, sigma Y, and then I have the correlation coefficient between X and Y times sigma X times sigma Y would equal the covariance between X and Y. Okay. And we're often, very often, going to use this instead of this in our formulas because correlation coefficients are often data that we find available. And so this correlation coefficient version of the covariance is something we use a lot. Okay, now having said that, excuse me, let's then look at the decomposition of portfolio return variance formula for a two-stock portfolio. It says, I'm going to use different notation, the variance of the return for a portfolio of two securities. Remember, this is the same as the var return portfolio of two securities that I've used in the past. Okay? That's equal to, if we have x and y, the weight in x squared, sigma square x, plus the weight in y squared, sigma square y, plus 2 times the weight in x times, oops, two times the weight in x times the weight in y, covar x, y, right? And now I'm just going to plug in for this. I'm going to plug in this. So that means sigma square return, the variance of the return for a portfolio of two securities, the variance of return for a portfolio of two securities, decomposition of portfolio return variance for a portfolio of two securities is the weight in x squared times var x plus the weight in y squared times var y plus 2 times the weight in x times the weight in y times the correlation coefficient between x and y times standard deviation of x times the standard deviation of y. So this is a formula we'll look at. It's still a decomposition of portfolio return variance. It's just instead of covar, we have the alternate version that involves correlation coefficient, which looks like this. Okay. Well, having said that, we're going to see that it is this term that has a lot to say about where the feasible set lies in that triangular area that we talked about before. Let's see how it works. Okay, so we'll draw the two space, mean historical returns, standard deviation of returns historically, and x and y. And here's a quick look at what happens. This line can be, I'll draw 5 of them. It can be that, or 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 it could be that. Any of those 5, depending upon the value of that correlation coefficient. My next video is going to be a video of a spreadsheet that shows this quite nicely, but just now to give you some additional info on this. This straight line right here is the circumstance where the correlation coefficient between x and y equals +1. This 2 straight line segment here that goes like this and like that is the circumstance for is the shape of the feasible set if the correlation coefficient between the returns of x and y is -1. And these other ones in between are for circumstances when the correlation coefficient between the returns of x and y is somewhere between +1 and -1. And that's enough for this video. In the next video, we'll look at this again on a spreadsheet. Thanks for watching.